Hi there, this is Jacob Nash, and in this video we'll talk about inverse functions. Oh yeah, that's not, don't really like that, but we still have to do it. So what are these? Inverse functions, pretty much, if you want to say in simpler words, they kind of just are the reverse of each other. So kind of their domains and ranges are switched. So let's look at an example. So if we had one where if you put in 1 for x, it resulted in 2, then the inverse function, which we will put a -1 right there like that, the inverse should be result in the opposite. So this x resulted in this y, this x resulted in this y, but they're opposite. So that's how you know they're inverse functions. In the last video, we talked about exponential functions, and they're actually the inverse function of that is the logarithm function. And if you remember, the way that's easy for you to change between these is this. You use this format. And once again, I don't want to say it too many times, but I have videos on this. But so this is a really good, easy way that you can switch between them. So I just always remember a to the c equals b, and then just ABC goes along there. That's all you have to do. So let's say we had 7 to the x equals 49. Well, at least you probably know what that is. But pretend like it was something that was harder that you couldn't know in your head. You would do it like this. All you have to do is type that into the calculator. And if you have a calculator that can't do this, like you're not able to choose this lower number, you would just do log 49 divided by log 7. And the answer you should get is 2. So these are inverses when they're as functions. That's just like in general what I just showed. So let me do this. A couple logs that you're going to want to remember just as a side note is if you remember this ln, what is that? What is that ln? Do you remember? Well, ln of x actually would just mean if it was log that has a base of e. And what is e? E is one of those numbers, kind of like pi, that's a constant, and that means it's the same thing every time. E is approximately 2.72 or 2.73. Sorry, 2.72. I shouldn't have doubted myself. 2.73, that 273 is a number. That's probably why I thought that first, because that's a number that sticks with me. But anyways, that's what ln means. And another thing that's good to know is when it's just log of x like this, it actually means that there's a base of 10. That's important because apparently I've heard that some textbooks will actually, and some teachers you may have had, may try to use these interchangeably, which is not right, obviously, because 2.72 is not close to 10. So just be careful about that because that's what you're going to need to know now. Now let's look at how would you find the inverse function? And furthermore, how would you prove? Which is, like I said before, that's something you might need to start doing in this course. So let's just think of an example here, okay? Let's just do this, 8. F of x equals x to the 8th. The good way to do this, and if you recall, this is actually the same thing as y, and this doesn't have to be f of x, obviously. It could be g of x, anything of x, whatever. What you have to do is switch these around, okay? So we put x here, and now we have f of x here, and it is to the 8th. And we have to solve for f of x. We get to take the 8th root, which is a little weird. We can take the 8th root, and then we find out that the inverse function, sorry, I should write it like that, is the 8th root of x. Okay? Now, the way to prove this, you might not always have to do, but it is definitely good to do. And we can do this by composition. So if you remember something a little bit funky like this that I've done in my videos before, if you happen to have watched the other ones, where it looks like fog, that's not actually O, that's when we do composition. And what does that mean? It means the same thing as if you wrote it like this, f of x, f, and in the x, you put g of x. So you're saying you put the y of the other in the x of the other, which sounds like crazy when you're trying to speak it out, but it just really means that you're putting the y of one into the x of the other, and vice versa. And if you do that, then it should equal the same thing in both. And that's how we can prove that it is a composite function, or sorry, not composite, inverse function. So going back to the example that we had, and we don't need to say g of x because that's not what we said. We'll just say this. So we're saying that we're putting the value, the y value of this into the x value of the original. So what is the y value? But remember the answer that we got was that the y, or f negative 1x, is, and that's not really what you should say, sorry, inverse of f of x is the 8th root of x. You plug that in there like that. And the next step that you have to do is when we had the x here, this is actually not correct. You need to actually do this because the x, it was x to the 8th. Remember, that was what the x value was, sorry. And so these cancel each other out and you're left with x. And if you did the same thing like this, sorry, this is really messy because I'm using my mouse. What would it be here? Well, it would be this instead, which is actually the exact same thing. So if you were asked to prove it, that's what you would have to do. I know that looks kind of crazy, but it's not that hard. You just plug in the other of the other. Like, I don't know how to say it, really. It's kind of hard to say in words, but you can see what I did there. So there you go. That's it for inverse function.